welcome to today's deep dive. Um, Today we are exploring the actual mechanics of accelerated learning.
Yeah, and we're pulling this primarily from Walter Isaacson's pretty extensive biography of Elon Musk.
Right, right. And I want to be clear right off the bat, our mission here isn't just to, look at a timeline of a tech CEO or just list off his companies.
No, not at all. We are going to systematically deconstruct the highly disciplined five-step architecture that's detailed in the book, the system he uses to master these incredibly complex subjects in record time.
Exactly. And to really grasp how radical this system is, I want to start with this amazing scene from the source material. So imagine you're walking into an office and there are several world-class software engineers just like huddled around a single monitor.
The stress in that room must have been palpable.
Oh, completely. Among them is Max Levchin, right? The brilliant engineer who co-founded PayPal. And they are completely paralyzed by this severe Oracle database problem.
Yeah, they are rapidly running out of time to fix this thing. It is a massive technical bottleneck. I mean, these are top-tier minds, and they are just completely stuck on the architecture of this specific system.
Right. And then Musk just walks into the room.
Just casually strolls in.
Yeah, he asks what the issue is. He listens to Levchin break down this incredibly complex breakdown in the architecture, and without hesitating, he just delivers a highly specific technical solution. Then he just turns around and walks out.
Which is just wild.
And the best part is the engineers actually start laughing. It feels like an inside joke to them because everyone in that room knows Musk has absolutely zero knowledge of Oracle database architecture. I mean, his entire reputation at that point was built strictly on Windows systems.
Right, he was the Windows guy. But they decide to, input his solution anyway, just to see what happens.
Which honestly tells you a bit about their desperation at that point.
Exactly.
So the diagnostic runs, the results populate on the screen, and the smiles just vanish.
Yeah.
And one of the engineers finally breaks the silence and just mutters, "Oh no, he is actually right."
That moment is so telling, right? Because it establishes a pattern. If we look at the timeline in Isaacson's book, we see this bizarre phenomenon scale up to a literal life and death scenario for an entire enterprise just a few years later.
Oh, you mean the SpaceX situation?
Yes, exactly. So SpaceX had just suffered its third consecutive rocket launch failure. I mean, the company was essentially out of capital, standing right on the edge of bankruptcy.
Yeah, if they couldn't secure immediate funding for a fourth attempt, the company was just done.
Right. So Musk reaches out to his former PayPal partner, Peter Thiel, asking for a financial lifeline.
And Thiel agrees to hear the pitch, but he sets a really fun condition, doesn't he?
Yeah, he says he wants to speak directly with the chief engineer before he commits a single dollar.
Which is a totally reasonable request for an aerospace investment.
Totally reasonable. But Musk just looks at him and says, "You are talking to the chief engineer right now."
And Thiel thinks it's a joke. I mean, they built internet payment software together. Thiel knows for a fact that Musk has absolutely zero formal academic background in aerospace engineering.
Yeah, when Thiel realizes Musk is actually designing the hardware, he is just floored. And this brings us to the core question of this deep dive, really. How does a software entrepreneur learn the unforgiving intricacies of advanced rocket science in such an incredibly short window of time?
Right. And when asked this publicly, Musk famously gave this really simple answer. He just said, "I read a lot of books and I talked to a lot of people."
Which sounds almost dismissive,
Yeah, it sounds like something you'd say to get out of a long conversation. But Isaacson's biography really pulls back the curtain to reveal that behind that casual quote is this relentless, almost mechanical framework for learning.
It's a system designed to completely bypass traditional academic bureaucracy.
To basically demolish artificial learning curves. So let's unpack the first step of this architecture, which is what Musk calls accelerating your cycle time.
Yeah, and this fundamentally flips traditional education and corporate training on its head. I mean, in traditional systems, whether you're talking about a university or a legacy aerospace firm, the prevailing philosophy is to plan endlessly to avoid making mistakes.
Right. Mistakes are penalized. You get a bad grade, you get fired.
Exactly. But accelerating your cycle time means you intentionally speed up your rate of failure. You force the system to break so you can learn from the immediate feedback.
I found the contrast Isaacson draws here so fascinating. Early in SpaceX's history, a senior engineer argues that manufacturing rockets at Musk's demanded speed is just physically impossible.
Right, because of the standard protocols.
Yeah, he points to the military's quote-unquote gold standard of engineering, where raw materials are put into these specialized isolation chambers, blistering heat, freezing cold for literally months before a single blueprint is even drafted.
And that is the conventional definition of rigorous engineering, right? But the methodology here completely rejects that premise. Musk's instruction to the team was just build a small, functional engine, mount it on a test stand, and fire it.
Just see what happens?
Yeah, and if it blows up, you analyze the wreckage, figure out the mechanical failure, fix it, and fire it again immediately.
But hold on, applying the software industry's move fast and break things mantra to a piece of code is one thing. Applying it to a highly explosive 10-story rocket seems incredibly dangerous, if not completely reckless. How does the book justify that level of risk?
Well, that's the natural pushback, right? But the methodology doesn't ignore safety, it isolates the risk. You don't fail fast with humans on board, you fail fast on the test stand.
Oh, okay, that makes sense.
Yeah. And a great example from the book is that crazy lightning storm incident.
Oh my gosh, yes.
So a bolt of lightning strikes the top of a massive SpaceX fuel tank at the launch facility. The sudden atmospheric pressure change causes the thick metal tank to cave inward, leaving this massive dent.
And the lead engineer just goes into absolute crisis mode, telling Musk the structural integrity is compromised and they need to manufacture a brand new tank from scratch.
Which will take months, right?
Right. But Musk looks at the dent and orders the engineers to grab heavy construction hammers, literally climb the tank, and physically beat the metal back into its original shape.
He even tells them that if the hammering causes any microfractures, they should just bring a welding torch up there and seal them on the spot.
Which sounds completely insane. I mean, these are aerospace engineers, not mechanics at an auto body shop.
It does sound absurd until you look at the physics of pressure vessels, which is the underlying logic Musk was applying here.
Okay, break that down for me.
So a rocket fuel tank is essentially a giant soda can. When it's pressurized from the inside, the internal force pushes uniformly outward. So as long as the material hasn't lost its tensile strength and the seals are perfectly welded, cosmetic imperfections just don't necessarily compromise the structure under internal pressure. Yeah, so they hammered it out, welded the cracks, filled it with highly pressurized fuel, and it held perfectly. They saved 4 months of manufacturing time right there.
That is wild. Reading that made me think about the difference between writing a 500-page manuscript and perfectly proofreading it in isolation for a year versus writing it in a shared document where people are live editing and critiquing your paragraphs as you type.
Oh, that's a really good way to look at it.
Yeah, like the first way feels much safer to the ego, but the second method forces you to confront your structural flaws instantly.
That live editing analogy is spot on. But here is where the logic kind of forces a transition into the next pillar.
Okay, how so?
Well, if you are intentionally breaking things faster to accelerate your learning, you very quickly run out of internal knowledge. You hit a wall where you literally don't know how to fix what you just broke.
Right, because you're moving too fast for your own current skill level.
Exactly. And you cannot rely on slow institutional manuals or academic papers to give you the answer. You need immediate access to deep knowledge.
Which naturally drives the second step of the framework, which is learning directly from experts.
Yeah.
Just bypassing the lecture hall entirely.
Yeah.
And the origin story of SpaceX perfectly illustrates this. So, after selling PayPal, Musk goes looking for a timeline for a Mars landing on NASA's website, right?
Yeah.
And he finds absolutely nothing.
Zero plan for Mars.
Right. So he develops this crazy strategy to buy a decommissioned Russian intercontinental ballistic missile.
Which, the underlying psychology of this plan is actually brilliant. He wanted to send a small greenhouse to Mars.
Just a greenhouse.
Yeah, he hypothesized that if the public saw a live green plant against the red Martian soil, it would trigger this massive emotional response globally, which would in turn force governments to dramatically increase funding for space exploration.
So it's essentially a PR stunt designed to manipulate the funding mechanisms of legacy aerospace.
Exactly. So he flies out to Russia to pitch this.
Yeah.
He sits down with these seasoned military and aerospace officials and gives them this grand presentation on making humanity multiplanetary.
And the officials are just completely cold. One of them actually asks him, "Who is your chief engineer?" And Musk replies, "I am." And they essentially just laugh him out of the room.
Yeah, they view him as an internet tourist. But the rejection isn't really what matters here. It's how the methodology responds to the knowledge deficit.
Right, he doesn't just give up.
No, he secures a second meeting with a different team and asks for the cost of a rocket. The official quotes him $21 million for a single launch system and brutally tells him to stop wasting their time because he doesn't have enough money.
And the flight back home is where the learning curve actually happens.
Yeah.
Musk sits isolated in the front of the plane, just typing furiously for hours, while his colleagues are wondering what he's doing.
Probably assuming he's just sulking about the rejection.
Right. But then he finally turns his laptop around to show them a spreadsheet filled with these complex thermodynamic formulas and engineering designs. He had figured out how to build a rocket from scratch for a fraction of the cost.
Yeah, and his colleague realizes at that moment that Musk had been aggressively borrowing his advanced textbooks on rocket propulsion for the past year.
Now wait, reading textbooks sounds exactly like traditional schooling. How does that fit the framework?
That's a good distinction to make. The source material clarifies that the textbooks were just his baseline vocabulary. The true acceleration came from how he used the people he hired.
The experts.
Right. He brought in world-class specialists in propulsion and structural design, but he didn't just assign them tasks to do in isolation. He used them as living, interactive textbooks.
So active interrogation versus passive reading.
Precisely. Passive reading gives you the theory, but active interrogation forces the expert to explain the practical application and, more importantly, the failure points.
Interesting.
Yeah, before any major decision, he would relentlessly question these experts, pulling apart their mathematical logic, trying to find the bedrock physics of their assumptions, and then fusing that into his own mental model.
Okay, so you've accelerated your cycle time, and you've extracted this functional knowledge from living experts. But once you possess that knowledge, standard corporate timelines suddenly become your biggest enemy.
Oh, absolutely.
If you have the answer today, but the bureaucracy schedules the implementation for next month, the speed is lost. That necessitates step 3, which is a maniacal sense of urgency.
The philosophy here is really simple. A good plan executed immediately is infinitely superior to a perfect plan executed next week.
Talk less, execute more.
Exactly. Action creates new data. Waiting just creates theoretical friction.
And there is a great anecdote in the book from an aerospace summit that shows this. Musk's team runs into an engineer from a defunct space startup who mentions this abandoned rocket testing facility out in Texas.
Yeah, the creditors were trying to liquidate it.
Right, so a senior engineer on Musk's team suggests they schedule a corporate trip to inspect it, over the next few days. And Musk cuts him off immediately and says, absolutely not. We are getting on our plane and flying down there right this second.
I love that part. So they arrive at this massive deserted industrial site. And the lead propulsion engineer gets super excited and starts loudly praising the high-volume water tanks and steel structures.
Just geeking out over the equipment.
Exactly. And Musk sharply whispers for him to shut up, pointing out that if the single security guard on site realizes how desperate they are, the price will skyrocket.
So smart. And a normal corporate acquisition would involve, flying back to headquarters, compiling a 50-page assessment report, sending it to the legal department, and scheduling a follow-up negotiation.
A total nightmare of red tape.
Right. But Musk skips that entire bureaucratic ritual. Standing right there in the dirt field, he calls the property owner directly and secures a binding 1-year lease on the spot for just $45,000.
Think about the massive advantage that creates. By bypassing the friction of traditional corporate diligence, he secures a critical physical asset months before a competitor would have even finished their preliminary risk assessment.
It's basically like treating heavy industrial acquisitions with the casual immediacy of clicking buy now on Amazon.
That's exactly what it is. But there's a catch. If you are constantly acquiring assets and iterating designs at this breakneck speed, you are going to generate a massive volume of output.
And sheer volume inevitably creates logistical bottlenecks.
Right. When things slow down because there are simply too many moving parts, you have to transition to step 4, which is simplify ruthlessly.
And this is really the application of the 80-20 principle, right?
Right.
The idea that roughly 80% of outcomes are driven by just 20% of the inputs.
Exactly. The framework demands that you aggressively strip away the 80% of overcomplicated noise that isn't actively contributing to the physical function of the product.
The book illustrates this perfectly with the Tesla Gigafactory in 2017. So the entire multi-billion-dollar production line is stalling because of one tiny bottleneck in the battery assembly area.
Yeah, they just keep running out of these custom-engineered plastic caps that have to be manually placed over the battery pins.
And when the caps run out, the line stops and the whole factory literally halts.
So Musk is on the factory floor, and instead of asking how to procure more caps faster, which is what a normal manager would do, he asks a fundamentally disruptive question.
He asks why they were putting these plastic caps on the pins in the first place.
Right. And the engineering team cites the official protocol. They say the caps are required to prevent the internal battery pins from bending or warping due to vibrations during transit.
But this is where understanding the bedrock physics comes into play. Musk analyzes the actual mass of the pins and the resonance frequency of typical shipping vibrations.
And what does he find?
He concludes that the pins do not have enough mass to bend under those specific vibration conditions. He declares the protocol a total illusion and orders them to eliminate the caps entirely.
And the engineers are terrified, right? They think thousands of batteries are going to fail in transit.
Oh, they're panicking. But they remove the step, and the pins don't bend at all. The massive bottleneck disappears instantly, and production capacity just skyrockets.
It's such a perfect example.
Yeah, and reading this section really made me look at my own schedule, and I think if you're listening to this, you should audit your own life. The 80-20 rule suggests we're all carrying around our own plastic battery caps.
Oh, definitely.
Processes, meetings, or habits we maintain simply because they've always been done, not because they actually drive results. What are the useless plastic caps slowing down your own daily processes?
That is a crucial insight for anyone listening, but it reveals the final hurdle in the framework. You cannot effectively cut the noise if you blindly trust the authorities that put the noise there to begin with.
Right.
You have to fundamentally distrust standard operating procedures, which logically leads to the fifth and final step question: every single requirement.
The rule here is basically to assume every corporate mandate, traditional guideline, or industry standard is fundamentally wrong until it is undeniably proven correct by basic physics.
Because blind adherence to legacy rules is the primary cause of bloated timelines and inflated budgets. Like, during the early days of SpaceX, the team needed a highly specialized aerospace-grade valve to control propellant fluid. The procurement team brings Musk a quote from a legacy aerospace supplier, and it is $150,000 for one valve.
And Musk rejects the quote entirely. He argues that the basic mechanics of the valve functions similarly to a standard garage door opener.
Right.
So he gives the team a maximum budget of $1,200
Yeah.
and tells them to figure it out in-house.
Now, to an outside observer, telling a rocket engineer to build a fluid valve with the budget of a garage door opener sounds like a recipe for a catastrophic explosion.
Exactly. I was reading this thinking, how in the world does a $1,200 part survive the extreme pressures of a rocket launch? Doesn't this whole innovative disruption thing cross the line into actual negligence here?
Well, it's not negligence because he isn't ignoring the physical reality of the rocket. He is ignoring the bureaucratic premium of the aerospace label.
Oh, I see.
Yeah, the engineers stripped away all the traditional aerospace assumptions and looked strictly at the fluid dynamics and pressure ratings required. And they discovered a heavy-duty mechanical valve originally manufactured for commercial car washing equipment.
A car wash valve.
Yeah. By modifying the internal seals to handle different chemical properties and re-engineering the structural tolerances, they created a perfectly functional valve for a fraction of the cost.
Wow. Because if the physics work, the bureaucratic rule that says an aerospace valve inherently must cost six figures is just mathematically false.
Exactly. And that modified car wash valve design is still flying flawlessly on SpaceX rockets today.
That is unbelievable. And they applied this exact same aggressive skepticism to the massive aluminum domes used for the high-pressure fuel tanks, too.
Right. They had a specialized supplier manufacturing these domes. And mid-contract, the supplier suddenly informed SpaceX that they're tripling the price for all future units.
The book likens it to a contractor painting half of your house, putting the brush down, and extorting you for 3 times the agreed price just to finish the job.
Yeah, and Musk just refuses to negotiate. He cancels the contract immediately and forces the SpaceX team to figure out how to manufacture these highly complex aluminum domes entirely in-house.
And this refusal to accept external constraints is why SpaceX evolved into such an anomaly in the industry. They manufacture over 70% of their entire rocket hardware completely in-house.
Which is a huge contrast to the rest of the industry. For context, legacy agencies like NASA rely almost entirely on a massive web of third-party corporate contractors for their critical components.
Right.
Which is exactly why their cycle times are so incredibly slow and their budgets are so high.
So when we synthesize all of this from Isaacson's text, we get a really clear chronological blueprint for mastering complex systems.
Let's recap it for the listener.
Yeah. First, you aggressively accelerate your cycle time, run toward failure to get immediate feedback. Second, when you break things and hit a knowledge gap, learn directly from experts by actively interrogating them, not just passively reading.
Third, apply that knowledge with a maniacal sense of urgency, bypassing traditional corporate friction. Fourth, as your output increases, simplify ruthlessly by eliminating the 80% of processes that don't drive actual physical results.
And fifth, to effectively simplify, you must relentlessly question every single requirement, testing legacy rules against fundamental physics.
But the source material includes one final, really essential detail. Even with this radical system, nobody does it in a total vacuum.
Right, he had help.
The book highlights that Musk's core mentor is Larry Ellison, the billionaire co-founder of Oracle.
Which is the exact same individual who mentored Steve Jobs.
Exactly. It underscores that targeted high-level mentorship is the ultimate accelerant for this entire framework. It really grounds the methodology. You break things, you interrogate experts, you move fast, but you still rely on the synthesized wisdom of those who have navigated massive scale before you.
It's the exact combination of factors that allows someone to look at a screen of Oracle database errors and casually drop the correct solution to a room full of specialists.
It's the secret weapon behind the whole thing.
Which leaves us with a final thought to really consider here. If this five-step framework allows someone to completely bypass traditional academic bureaucracy and master something as unforgiving as rocket science in a fraction of the time, what does the future of education actually look like?
That is the big question.
Yeah, if degrees are no longer the ultimate proxy for expertise, will the legacy institutions that grant them eventually become obsolete? Could they be replaced entirely by real-time failure, active interrogation, and targeted mentorship?
It's definitely something to think about.
Absolutely. Something for you to mull over the next time you find yourself stuck waiting for permission to test a new idea. Thanks for joining us on this deep dive.